like to get out there and tell people about this technology. We look after things like the Cilium website on behalf of the project and also eBPF. And I could tell you what it stands for, which is Extended Berkeley Packet Filtering. We love to kind of tell people about this technologies that we're really excited about. And eBPF is something that really grabbed my attention, a few years ago. And now I get to work with the world experts on it. It's fantastic.
Welcome to another edition of Cloud Unfiltered. This is a special edition at KubeCon in Paris.
Bienvenue à Paris.
Yes. And I have my guest here, Liz Rice.
Hello. Hi. Thanks for having me.
From Isovalent, which is in a little bit of a transition now, right?
Yeah, I mean, the acquisition by Cisco has been announced now for a few weeks. We haven't closed yet. Hopefully, I mean, who knows? By the time people are watching this, maybe it will have closed.
So
absolutely. Excited to become part of the Cisco family.
And we're absolutely excited to have you. So I think it's going to be an amazing synergy. So I'm very excited about it. So we've been in around this whole eBPF train for a while now. There was actually a movie that was actually really, really good. I watched it. And
Wasn't it great?
It was amazing. It was like a Netflix thriller for the tech world.
The production values on that were just amazing. I was so impressed with the team that put it together.
Absolutely, Chad and team, they were amazing.
Fantastic team, and really, we got all of the people involved right from the beginning to come and tell their stories and bring their perspectives. Because a lot of that is from the Linux kernel world, and it's really nice to kind of see those people on screen and hear their, recollections of what it was like back in 2014, 2015 when this was first being put in the kernel. And it was great. I love doing that.
Yeah. So, I mean, to back up a second, so let's explain to people who you are who don't know in my listening audience, if that's even
Good
possible.
Point. Yeah.
and I did forget to mention that. So why don't you introduce, what you do at Isovalent?
Yeah. So my role at Isovalent is Chief Open Source Officer. Myself and my team look after our community, essentially. We work, very heavily on the Cilium project. All our engineers are working on Cillium Open Source as well. We engage with the foundations. We like to get out there and tell people about this technology. We look after things like the Cilium website on behalf of the project and also eBPF.
Yeah.
And we love to kind of tell people about this technologies that we're really excited about. And eBPF is something that really grabbed my attention a few years ago, and now I get to work with the world experts on it. It's fantastic.
Yeah, so explain to people what eBPF is in layman's terms, because some people might not know what that is. So for my listening audience.
Yeah, so most people want to know what it stands for.
Yeah.
And I could tell you what it stands for, which is Extended Berkeley Packet Filtering. But you can forget that because it's so much more than packet filtering now.
Yeah.
We really think of it as just a standalone term. What it really is the ability to run custom programs inside the kernel. And the kernel is the part of the operating system that interfaces with hardware. We don't really think about it very much if we're developing applications, right? We just think, we can open a file or send a network message or whatever. But in reality, our applications have to ask the kernel to help with all those things that involve hardware. And if we can run custom programs inside the kernel, we can see all these interesting things happening. We can influence those things happening. We can block some of those things happening for security purposes. We can get involved with network messages, which is really the basis of the Cilium networking project.
Yeah.
And it's a really powerful platform sitting inside the kernel to be able to observe everything that's happening in a machine.
So this was something that has been there, but kind of expanded. So I think, if I remember correctly, it was like, IP tables kind of stuff was kind of like.
You can use it to replace IP tables.
Yeah, it was kind of, it started out with like a filtering mechanism is what I want to say.
Yeah, I mean that was the original mechanism.
Original intent.
Yeah, was this idea that you'd be able to make kind of dynamic decisions about which packets you were going to filter in or out of an observability flow. And so, there's a little bit of decision making there. There's a program there. And the inventors of eBPF, Alexei Starovoytov and Daniel Borkman, they kind of had this idea of extending that to do more more things, not just filtering packets, but what other things could we?
Now, how does that come about? You're playing around with it. You see there's something cool, and you're like, you know what? Maybe there's something tangential to this that I can figure.
I think so. Yeah, I think Alexei had a particular problem that he was trying to solve, and he kind of, realized that perhaps this was going to be a good way to solve that problem, and he came up with this idea of running a kind of fully fledged instruction set inside the kernel and having a virtual machine essentially to, initially interpret, and now it's compiled, execute those instructions. And over time, you've been able to, the set of things that you can do has extended, the set of places where you can attach these programs has extended, and it's now become this incredibly powerful. In fact, if I want to kind of preempt a talk that I'm doing on Friday with my colleague John Fasterband, and the talk's titled eBPF, Its Abilities and Limitations, The Truth. And to cut to the chase, we are going to show that there is no limitation to what you can do with eBPF today.
Wow.
John has written an implementation of Game of Life in eBPF, and that is basically, it demonstrates Turing completeness and the ability to sort of continue processing an arbitrary amount of data. And it's pretty fun.
That's amazing. I mean, when you think about it, I love, and one of the things I often talk about on this show is how things came about, how they evolved, how they, what made somebody, kind of bang their head on the wall so many times when they're like, there has to be a better way.
Yeah.
And so I love the origin story of why this stuff occurred.
Yeah. And I think also, Daniel particularly was looking at it from the networking side and working with other people who founded the Cilium project, realizing that you could do things like hook into the networking stack and bypass IP tables and bypass parts of the stack and drop packets according to some dynamic policy. So I think little by little it's gradually grown into this incredibly powerful environment, if you like, the platform.
Yeah. I mean, it was so popular, and we were just talking, pre-show that probably a couple past KubeCons ago, it was like the talk. Every KubeCon, there's kind of some theme that is prevalent, and really that was the main one. And I'm not saying it's not still; it's very, very prevalent. But there seems to be a theme each year, and eBPF was just so,
Yeah, and we see a ton of projects now out there using eBPF for lots of different purposes, which is fabulous.
Yeah, absolutely. So how does that translate to what happens to Cilium? What are we taking advantage of there?
So Cilium really focuses on networking, although we kind of surround that with security and observability specifically of networking. And I can come to Tetragon, which takes it even further, but we'll park that for a moment and come back to it. But
don't give my audience everything at once. Come on.
but really with Cilium, I mean, I think the vision right from the get-go was this idea that, if you're running these multiple containers, they have kind of virtualized networking that can be done so much more efficiently with eBPF, because you can create these sort of dynamic, very, very short connection. You don't need to run through the whole kernel networking stack to pass a packet from one place to another. You can potentially pick it up with eBPF and put it somewhere else. And because we can not just manipulate or redirect packets or drop them, but we can also manipulate them. So that allows us to do things like load balancing. It allows us to do things like, routing packets depending on the content. And increasingly, we want to push that kind of networking-related functionality into the kernel where it belongs in the networking stack. So if you cast your mind back, several years now, TCP used to be run in user space. Yep. And now nobody expects to run TCP for themselves. And nobody expects to, configure their own TCP stack. Just expect the platform to take care of it for you. And as we have increasingly complex networking requirements from applications, all these things like, gateway API, things that have traditionally been associated with service mesh, like load balancing or canary rollouts, a lot of these things we're increasingly able to do with eBPF. Some of these things we don't do in eBPF today, but I think more and more of that functionality is moving in that direction, where it can be super efficient.
Which is amazing for multiple reasons now, because, I come from working with Istio, working with, different service meshes and things like that. And really one of the things that I'm always concerned for the community, especially people getting into it, is the amount of different elements that you need in like a Kubernetes stack, or you need in, so if you could have more of those things in less solutions, that, and make it less complex for people, that to me is always on my mind these days.
Bill Mulligan in my team did a fabulous, he's great. He found there was a really, I want to say it was XKCD, it might not have been, but it was a cartoon that has all these like layers of the stack, and you can basically cross them out and put Cilium in place instead, and he kind of repurposed this cartoon, and it's so true. There's probably half a dozen different things that previously maybe you had a separate tool for each of those things that Cilium can now take care of for you, and in a very kind of efficient, straightforward way. I mean, I'm doing a talk later today about cluster mesh, and cluster mesh is all about running workloads across multiple clusters in multiple clouds. And really, you're just putting an annotation on a service to say, we're going to share this across clusters. And it's kind of almost too easy. The first time you do it, you think, really? Is it that easy? And that's, the power of Cilium and the power of eBPF, making things shouldn't have to be complicated. Not everything needs to be, super heavyweight and complicated. And if we can make things easy to use and simple and efficient, all to the good.
Yeah, the one thing that I did love about the whole Kubernetes kind of topology and things like that was annotations were so powerful. And I love when you can take advantage of those things to do other things, and it's just getting smarter and smarter about all these solutions out there that can just do stuff under the hood that you don't even have to think about anymore, and things like that show the power. I mean, I'm dating myself, but I was a network engineer when I first started out, and I worked with service providers, and we were doing BGP to the service and BGP to the edge, and and all this kind of complexity. And you're still doing those things now, but now it's coming to this this kind of deeper layer. And it's easier to configure. It's easier to maintain. It's it's GitOpsable, if that's a word.
Yeah, absolutely. I mean, BGP is another example of something that's moving into Cilium. So we now have the ability to announce pod IP addresses with BGP, for example. And it's a whole other, it's a component that you don't need to have a whole other tool to do. And we like to make things easier.
Yeah, and that's my goal in life is to help facilitate that. To either have guests on that tell how to make it easier, or talk about these products that or solutions that can make it easier, or even just talk about how to get started in something like this that seems so complex to people that haven't been kind of growing up with it like a lot of people in the community have. So it's awesome when there's solutions like this that can just help with that.
Yeah, I do think, for somebody who comes to the cloud native landscape today with, I don't know how many hundred projects there are on that landscape.
It's like 5,000 projects, not CNCF projects, but 5,000 projects on the landscape.
On the landscape.
Yeah, it's ridiculous.
And, I don't envy them trying to come to that fresh. And well, it must be a bit overwhelming. So trying to point out the kind of highlights and, start with Kubernetes. Hopefully, use Cilium for your networking solutions. Some of the very prominent, Prometheus would be another example of something that kind of everybody uses, and you probably do want to use that for your metrics, and maybe don't get overwhelmed by the 5,000 things right from the get-go, because nobody can learn them all. Right?
Yeah, I mean, you have these people out there that there's, either their CIO or CTO has told them, we want to be cloud first or cloud native or whatever it is. And you're like, I heard of that thing called Kubernetes. I'm going to check that out. Oh, what's a CNI? Oh, what's a CSI? What are these 5,000 different projects? And by the way, I got it up and running, but now I have this thing called prod that I want to do.
Yeah.
What kind of policies do I need? What kind of,
Yeah, and you mentioned before we started recording about platform engineering as a theme, and I think that's exactly speaks to this kind of idea of, we just want to give people a platform. We don't want our developers to have to think about all these details. We just want them writing business applications and being able to run them in the cloud.
Yeah.
And I think that's really what platform engineering is aiming to do. And then people, for some people it's just that kind of developer sort of portal angle. For other people it's all the way down to networking and security. All of those things are constituent parts of the platform that people are going to be using.
Yeah, and I often talk about this, so people are probably getting tired of me talking about it. But I think that a lot of people are concerned with the wrong thing, which is like, how do we set up this platform for our apps? And really, it should be, well, what is your app's requirement, and does it even need a certain platform? What do you need? Do you need scalability? Do you need multi-region? Do you need multi-zone? Do you need, think about your requirements and then back into the platform, back into those needs. And too many people are like, well, I'm just going to create something for Kubernetes, or I'm going to create something for and I think that's the kind of the wrong approach. Because really the end objective is that you have a scalable app that you can iterate on fast.
Yeah.
And so what is going to enable you to do that? Then back into the technology stack. I'm not saying it's the wrong technology stack. I'm saying it's the wrong,
ask the right questions in the right order.
Questions in the right order.
Yeah. Yeah. It reminds me of, when consultancies, and they'll have companies come to them and say, we want this Kubernetes thing. Well, why? Have you thought about why?
Yep. Absolutely.
And there could be really good reasons, but you need to have understood what those reasons are before you start putting the platform together. Yeah.
Yeah, and I mean, it was just like when the cloud providers came out, and every CIO was like, we want to be cloud first. Mm-hmm. Why? And then they forced that, and so then you had what was called a very, very expensive second data center in the cloud, because nobody scaled it right, nobody created different scaling policies and CPU policies and all these things. So it was just a very expensive second data center.
Yeah.
So tell us about, you mentioned another element you said we'll get to later.
Oh yes, Tetragon, yes. So Tetragon is a sub-project under Cilium, and it comes from actually initially conversations that Isovalent had with our customers with the sort of enterprise distribution, and they're seeing network policy that can block traffic based on source or destination workloads and Kubernetes identifiers and all this really powerful stuff that can prevent malicious traffic. But then the question is, well, okay, having seen traffic that we want to block, can we tell why it's there? Like, have we been compromised? Has there been some kind of malicious activity that created this malicious traffic? And with eBPF, we can, we know everything about the context, or we can find out everything about the context of, where a network packet came from. If it came from a socket, what's the application that created that socket? What container is that running in? What node is that on? How does that relate to your Kubernetes kind of identities? And so we built and open sourced this Tetragon sub-project in Cilium, which gives you this ability to detect events. So think of it more like runtime instead of just networking, but also runtime events. So it could be network related events from which you can find out what was it that caused this network event, or it could be other things like opening sensitive files or privilege escalations, being able to understand why these potentially malicious things have come about. How did we get compromised? When did this happen? When did this executable start that has opened this really dodgy connection to a cryptocurrency miner? So it's super powerful. And it also I think this is, I think Tetragon is the only example of this where we can not just detect things in eBPF or in the kernel using eBPF, but we can also block things synchronously from within the kernel. We're doing in-kernel event filtering, which makes it super efficient. There's some measurement being done that was showing some really useful default policies with less than 2% CPU overhead, which is
Wow.
incredibly good.
Yeah.
Because we can filter out, do all the filtering in the kernel, we don't have to sort of send every event to user space to be assessed, and only pass up to user space when there's something that is suspicious. And it's really, really powerful, and a lot of fun showing it to people and getting their kind of like, oh wow, you can do that kind of reaction.
Yeah, I mean that's amazing. I actually was not that familiar with that project, so that's pretty interesting.
Come by the booth and get a demo. Yeah,
I will definitely do that. But that's really, really cool. So how are you seeing and that's a community project?
Yeah.
And how are you seeing the community kind of ideate off of that?
I mean, one thing that springs to mind, I know there's a talk this week about using Tetragon as a kind of honeypot. And it's a really interesting project where they're detecting malicious events and using that to create a kind of open source database of threats, like real life threats that are happening out there, which I think is really, really great. I mean, there's not a lot of open data about real life attacks. So if they publish, real results about what, we talk a lot in security about possible threats, but I think it will be really great to see some data on what are the attacks that are actually taking place.
Yeah, I mean that's awesome. I mean, when I think about when I was in cybersecurity, there were definitely honeypots still, but they were on a totally different level, and you get different data that you would get, using this. So I mean that's pretty cool. I would love to see that project, honestly.
There's all sorts of things I think that can be done with this information, whether it is an enterprise getting that data and putting it into a SIM and having like the forensics, or whether it's about the real-time prevention, or whether it's collating data like this. There's endless possibilities.
It must be pretty cool from your perspective to see what people do with all of this, because a lot of it's probably not what you even thought about or intended, or
Well, definitely, yeah, and the team is incredible. The number of times I'm like, oh yeah, that was a really good idea. Whether that's come from Isovalent people or other people around the Cilium community, it's always great to see. I just love hearing about clever ideas.
I'm the same way. Trust me. But I'm curious. If you're creating stuff in the kernel, like eBPF, is there a danger of like what kind of, you really have to evaluate that code that goes in?
Yeah, well, there's I think the thing that makes eBPF so incredibly powerful is this thing called the verifier, which checks that your code is going to be safe to run.
That's awesome.
Can't tell you whether it's malicious or not, but it can tell you whether or not it's going to crash the kernel essentially, or whether the memory access is safe, that kind of thing. And that is a real game changer in terms of if you write a kernel module, it's pretty easy to build something that's going to bring your machine down. It's basically impossible with the verifier, because it's going to analyze every possible path through your code and ensure that all memory access is safe, and as expected, and that different operations are done in the context that they're expected to be done in. And it's it can't, as I say, it can't stop you. It can't tell the difference between, if I write a program to drop packets, it can't tell whether that's good network policy or I'm just being malicious. How can you tell? You can't tell the intent. So it is very important to only, to run eBPF programs as if you were, doing something with root privileges. Don't let just anybody in running any old eBPF thing in your deployment. That could be.
Yeah. Well, this is one place where I think the fact that it's open source really does help, because you have a lot of people looking at this. You have a lot of people, verifying it. And it's a big community, so it really, really does help in this scenario.
Absolutely, yeah. And I mean, we've been having people running Cilium in production in I don't know, thousands of different environments for years now. So pretty well proven, I would say at this point.
Yeah, absolutely, absolutely. I mean, I'm definitely a Cilium fan. So I was talking to to Duffy this morning, and he was telling me that if you're interested in a lot of this, there's actually a day that you can come and or there's an online thing that you can do to learn more about eBPF and
all sorts of things. Yeah. So Isovalent has a whole family of labs.
Yeah.
Really great collection of labs. Right from kind of beginner, getting started with Cilium, entry-level things about eBPF programming as well, right up to some really complex, much more advanced cases. You spin up these labs, explore that particular feature. Some of those labs have like little badges that you can earn as well, which people seem to love. So that's a really great resource that the team have been putting together. And then if you are, you really want to be able to demonstrate your Cilium knowledge, there is a new CNCF certification, a Certified Cilium Associate exam that is now live. It was announced at the last KubeCon, and it is now
awesome.
Up and running, and people are starting to, publish their CCA certification on, put it on their LinkedIn profile, and that's fantastic because, it really shows that this is having these certifications. It's kind of a proof point of enterprise adoption in many ways. It's something that people want to be able to say, I know about Cilium. I have not exactly the bit of paper, but the bit of virtual paper to prove that I'm, I have some expertise in this area, and that's valuable for their careers. And I think that's pretty cool.
So if we're getting towards the end, so if people wanted to learn more about Cilium or get involved in the community, that's even a better question. What do they have to do?
Well, many different routes into the world of Cilium. Cillium.io is the website. That's probably a great starting point, and we have all sorts of resources there. There's a weekly developer meeting. We have myself, Duffy, and some other folks around the community host a YouTube show on Fridays called Echo, which is eBPF and Cilium office hours, kinda, if you squint. But yeah, we try and cover all sorts of things about Cilium and eBPF projects around the community. So that's kind of a nice way to sort of virtually meet people, because we do it live. So it's always lovely when people comment. Yeah. If you're here at KubeCon, we've got the Cilium booth, we've got an Isovalent booth. There's all sorts of
Tetragon.
Yeah, well, Tetragon is present in
Cilium.
both, so it's part of Cilium. Yeah. Okay. There's loads of talks from all sorts of people around the whole community this week. I want to say there are 26 Cilium talks.
That is amazing. That must make you feel good.
Oh yeah. and it's fantastic to see, something that, I've only had a small part in building Cilium. It's it's absolutely standing on the shoulders of giants here, but to see that then being taken and other people, creating content about it, building talks, sharing their learnings about it is great. It takes on a life of its own.
That's amazing. So we are here at KubeCon. What interests you these days? Is there something that you're excited about? Is there something that that you're just walking around that caught your eye?
Well, it's day one, so I haven't been around the vendor booth yet. So it'll be interesting to see what's out there. It's very clear that AI is a big topic this year. I personally feel a little bit like I don't want to get too distracted by that. I think the infrastructure requirements of that could be really interesting, and the scale that people need to operate at are really interesting. And I'm kind of intrigued to see what networking and security related problems, how they evolve in this kind of world where we're doing a lot of AI model training and LLMs and so on. There's going to be interesting to watch, but I definitely, the world of eBPF is where my heart lies right now.
Well, that's amazing, and I do appreciate you coming on the show. This has been an amazing episode, and definitely wanted to have you on for a while. So
glad we were able to do it.
All right. Well, thanks again, and we'll talk to you soon.
Absolutely.
All right. Thank you.
Thank you.